structure associated with a table or view speed retrieval of rows from the table or view. An index contains keys with from one or more columns in the table or views. For these indexes, these keys are stored in a structure, B-trees, that enable SQL Server to find the rows or rows associated with the key value quickly and efficiently. An index stores data logically organized as a table with rows and columns, and physically stored in a row-wise data format called row store, or stored in a column-wise data format called column store. The selection of the right indexes for a database and its workload is a complex balancing act between query speed and update cost. Narrow indexes or indexes with few columns in the index key require less disk space and maintenance overhead. Wide indexes, on the other hand, cover more queries. You may have to experiment with several different designs before finding the most efficient index. Indexes can be added, modified, and dropped without affecting the database schema or application design. Therefore, you should not hesitate to experiment with different indexes. The query optimizer in SQL Server reliably chooses the most effective index in the vast majority of cases. Your overall index design strategy should provide a variety of indexes for the query optimizer to choose from and trust it to make the right decision. This reduces analysis time and produces good performance over a variety of situations. To see which indexes the query optimizer uses for a specific query in a SQL Server, Manage Studio. On the query menu, select Include Actual Execution Plan. Database consideration. When you design an index, consider the following database guidelines. Large number of indexes on a table affect the performance of insert, update, delete, and merge statements because all indexes must be adjusted appropriately as data in the table change. For example, if a column is used in several indexes and you execute an update statement that modifies that column data, each index that contains that columns must be updated as well as the column in the underlying base table, heap or cluster index. Indexing advanced table may not be optimal because it can take the query optimizer longer to traverse the index searching for data than top performance a simple table scan. Therefore, indexes on small tables might never be used but must still be maintained as data in the table change. Indices on view can provide significant performance gains when the view contains aggregation, table joins, or combination of aggregation and joins. The view does not have to be explicitly referenced in the query for the query optimizer to use it. Use the database engine tuning advisor to analyze your database and make index recommendations. When you design an index, consider the following columns guidelines. Keep the length of the index key short for clustered index. Additionally, clustered index benefit from being created on unique or on non-null columns. Columns that are of the next and text, image, varchar, and bar binary. Data types cannot be specified as index key columns. However, varchar, bar binary, and XML data types can participate in non-cluster index or as non-key index columns. An XML data type can only be a key column only in a XML index. SQL Server 2012 SP1 introduces a new type of XML index known as a selective XML index. This new index can improve querying performance over data stored as XML in SQL Server, allow for much faster indexes of large XML data workloads, and improve scalability by reducing storage costs of the index itself. After you have determined that an index is appropriate for a query, you can select the type of index that best fits your situation. Index characteristics include the following: clustered versus non-clustered, unique versus non-unique, single column versus multi-column, ascending or descending order on the column in the index, full table versus filtered non-clustered table indexes, column store versus row store, hash versus non-clustered for memory optimized tables. Clustered index architecture. In SQL Server, indexes are organized as V-trees. Each page in an index V-trees is called an index node. The top node of the V-trees is called the root node. The bottom node in the index are called the leaf node. Any index levels between the root and the leaf nodes are collectively known as intermediate level. In a cluster index, the left node contains the data page of the underlying table. The root and intermediate level nodes contain index page holding index rows. Each index row contains a key value and a pointer to either an intermediate level page in the B tree or a data row in the left level of the index. The page in each level of the index are linked in a doubly linked list. Non-clustered index design guidelines. A non-clustered index contains the index key values and rows locators that point to the storage location of the table data. You can create multiple non-clustered indexes on the table or indexed view. Generally, non-clustered indexes should be designed to improve the performance of frequently used queries that are not covered by the clustered index. Similar to the way you use an index in a book, the query optimizer searches for a data value by searching the non-clustered index to find the location of the data values in the tables and then retrieves the data directly from that location. This makes non-clustered index the optimal choice for exact match queries because the index contains entries describing the exact location in the table of the data values being searched for in the queries. For example, the query the human resource employee table for all employees that report to a specific manager. The query optimizer might use the non-clustered index EX employee manager ID. This has manager ID as its key column. The query optimizer can quickly find all entries in the index that match the specific manager ID. Each index entry points to the exact page and row in the table or cluster index in which the corresponding data can to the exact page and row to retrieve the data. Unique index design guidelines. A unique index guarantees that the index key contains no duplicate values and therefore every row in the table is in some way unique. Specifically, a unique index makes sense only when the uniqueness is a characteristic of the data itself. For example, if you want to make sure that the values in the national ID number column in the human resource employee table are unique, when the primary key is employee ID, create a unique constraint on the national ID number column. If the user tries to enter the same values in that column for more than one employee, an error message is displayed and the duplicate value is not entered. Filtered index design guidelines. A filtered index is an optimized non-clustered index especially suited to cover queries that select from a well-defined subset of data. It uses a filter predicated to index a portion of rows in the table. A well-designed filtered index can improve query performance, reduce index maintenance cost, and reduce index storage cost compared with a full table index. Filtered index can provide the following advantage over full table index: improved query performance and plant quality, Reduce index maintenance cost. Reduce index storage cost. Now my partner will show you how to use index.
A continuación mostraremos un ejemplo de cómo se realizan los índices cluster y no cluster. Los índices cluster son aquellos que se guardan de manera física en el disco. También son aquellos que vienen por default con los primary key. Me dispondré a mostrar cómo se crea un índice cluster. Ahora mostraremos cómo se crea un índice no cluster.